We have two problems here that are similar. We have three logarithms. I got a positive, negative, negative. And over here, in 37, I got three logs, a positive, a negative, and a negative. Now what I want to do is write them as one single log, right? Write each one as a single logarithm, the logarithm of something. So I'm going to use those log properties. And the log properties say I have to have the same base on each log if I'm going to combine them. I know if these are all log base 2, these are all base 10. So I can use those properties to combine. So first of all, I'm going to do this one step by step. And then I'm going to do this one over here, 37, just from here right to the end in one shot. So the first thing I'm going to do is bring these multipliers up as exponents. So I'm going to have the log base 2 of x to the 1/2 minus the log base 2 of y to the 3rd minus the log base 2 of z to the 4th. Okay, all I did is I brought those multipliers up as exponents. Now, what have I got here? I'll just do this one here. This is the log of a quotient. So this is going to be the positive log, right? As soon as I see a minus sign, I'm going to put that quotient in there. This is the log of 1/2 over y to the 3rd, and then minus the log base 2 of z to the 4th. Now, what do I see again? I see a minus. So this is going to be the log of this divided by this. Now, it gets a little complicated here. So we have to be careful. Log base 2, log base 2. All right, so it's going to be x to the 1/2 y cubed, all of that over z to the 4th. Now, this is really, okay, I've got a fraction divided by z to the 4th. All right. This is the log base 2. Here's what this is. If I make everything fractions, over what? Z to the 4th over 1. Then what do you do with fractions? You invert, right? You invert the divisor and multiply. So this becomes the log base 2 of x to the 1/2 over y cubed times, now instead of z to the 4th over 1, I will invert that, and 1 over z to the 4th, and then when I multiply, I just multiply tops together, bottoms together. So this one comes out to be this, the log base 2 of, okay, x to the 1/2, y to the 3rd, z to the 4th. But look at all of these steps here. I think we can go from the beginning, right, that first line, all the way to the last, if we just do this. Look at your first line. You want to combine those logs. Do you see minuses? You sure do. I see a minus here and a minus here. So as soon as I see a minus, I'm going to draw a fraction bar. So I'm going to do that right here. I'm going to have the log base 2 fraction bar. Now, all the positive logs go on top. So what goes on the top? Well, bring the 1/2 up. What goes on the top is x to the 1/2. If I can get it to right. And what goes on the bottom? The bottom, those are the negatives. The minuses go on the bottom. So what are the minuses? Y cubed z to the 4th. So I'll put a y cubed z, come on, z to the 4th. So look what I did. I went from here to here in one step instead of all of this, especially with that kind of cumbersome division. Now with that in mind, can you do number 37? So put it on pause, see if you can do it. Write it down. I'll do it here in just a minute. So I've got the log. I've got 3 logs. I'm going to write them together as just one log. And I see minuses. Yeah, every time I do this, I look to see if there's minuses. Is there minuses? I put a fraction bar. So I'm going to have, now this is the log base 10. Minuses, fraction bar. What goes on the top? The positive logs. Here's a positive log. So what goes on the top? 3/2 comes up as an exponent. So x to the 3/2. And what goes on the bottom? The minuses. So bring the 3/4 up, bring the 4/5 up. So this is going to be y to the 3/4 z to the 4/5. Now for both of these, 35 and 37, I could do something else. Sometimes when you see these fractional exponents, like down here, I'm at the bottom left, and up here in 37, sometimes you might want to write those with radicals instead. So for 35, I'm going to get rid of the 1/2 and write it as a square root. So I could write this as log base 2 of, okay, fraction bar, square root of x over y cubed z to the 4th. And in 37, I've got three rational exponents. I'm going to convert those to radicals. So how about if we wrote that as the log base 10 of, okay, this is going to be what? Now the bottom number tells you the root, the top number tells you the power, so this is going to be this square root of x cubed. In the bottom, we're going to get the 4th root of y cubed and the 5th root of z to the 4th.